So this is 42. This is the one you're referring to, or did I miss? Is that right?
Yeah, that's right.
Okay. So for this one, you're used to making. Well, I take that back here. What is 6.3? Is it truly? It's just techniques of integration, right? Okay. So let's say we let u, and you have to know this. Let's say we let u equal 1 minus x squared. Is that something you've seen in class before?
Yeah.
Okay. Now, normally you do a du and a dx, but it doesn't work out nicely with this one. This requires you to solve for x cubed. You're like, well, how do I do that? Well, if you move this over, so you make it x squared equals u 1 minus u, by moving the u right and the x squared left. Hopefully you caught that. You can raise both sides to the 3/2 power. So this becomes x cubed on the left equals 1 minus u to the 3/2 power. Okay, and you're like, why is that? You know, how does that help here? Does it help? It doesn't help on this one. Maybe this is a different type. Sorry, give me just a moment here to work through this. Sorry, I'm looking this over. I'm for some reason I'm stumped. Let me just a moment here to look something up real quick.
All right. This I have a problem like this in my notes.
Yeah, I've got the right.
Here's that problem, but x to the third isn't there in my notes.
Yeah, if it's just x, it works out nicely. So the substitution here is u equals 1 minus x. U is 1 minus x squared. Okay, take the constant. I'm looking at a solution online, and that is what they get here. But
we just did, for this problem, we just did trig substitution. We substituted x squared with sine squared theta.
For you didn't have trig functions in this. You did this one without trig functions.
Yeah, it looked exactly like that, but the x to the third wasn't there, and we substituted 1 minus x squared with 1 minus sine squared theta.
Okay.
And then it was 1 minus sine squared theta is equal to cosine squared.
Right. So, okay. So I see what you're doing. All right. So your instructor, okay. So you're doing x equals sine theta. Right. And then when you do x squared, it's sine squared theta. Okay. And then you have to also take a derivative of this. So dx equals derivative of sine is cosine theta d theta. And then you start putting in stuff here. So it's instead of x cubed, we didn't get to x cubed yet, but x cubed from this line would be sine cubed theta. So you have sine cubed theta
Right, yeah. Yep.
square root of 1 minus sine squared theta d theta. I'm sorry, what? No, let me not do that. And dx though is cosine theta d theta.
Right.
So now this inside here is the square root of cosine squared theta,
Uh-huh.
which is just cosine theta when you
Yes.
square root it. Okay, so this becomes the integral of, and these are how sophisticated these get. They get pretty so sine cubed theta, cosine theta d theta becomes integral sine cubed theta cosine squared theta d theta. Is all of that clear up to
Yes.
that step? Okay.
And then we set new bounds.
Yeah, we're definitely do that. I wait until the end. I mean, you could, because you can actually back substitute, but if you want, you can do it right here. You have to do them in this original line though. So you have to find like x of 0 is sine of 0 and x of 1 is sine of 1, which doesn't make any sense, but that's what it would be. So we might want to wait till the end for that.
Oh, yeah.
All right, so from here, you do make a u substitution. This is also a known one. So let me pull this up. Integral table. So see how the exponent is odd with sine and even with cosine.
Yes.
That's a special like case here, and you don't want to do it by hand unless you have to. So I'm just trying to get this reference sheet that will make this a bit faster. So let me pull this and snip this in and show you here. So when you get it down to something like this, it says if n is odd, and that's the case here, okay, strip one sine out and convert remaining sines to cosine using this and use the substitution u equals cosine x. So this is case number 1 here. And if you wonder where I got this, I'm going to send this to you in the chat. There's way more of this in this class than in the other one, because it's kind of so in short, you set u equal to cosine theta. So du equals minus sine theta d theta. And it also says to strip one sine out. So you get sine theta 1 minus cosine squared theta. This becomes sine theta sine squared theta.
Right.
And then you have this cosine squared theta. So now you can actually, I can't erase that. You can substitute in. So this becomes integral sine theta 1 minus u squared times u squared, because that's squared, okay? And then your d theta is du over minus sine theta. So see how those cancel?
Why did it go under?
Because you're solving this for d theta. This d theta equals du over minus sine theta.
Okay.
Okay, so this negative, now we're going to apply it to each of these, so it flips the order. It becomes u squared minus 1 times u squared. And then you distribute in u to the 4th minus u squared du. Okay, and then you can finally find the antiderivative of this. It's 1/5 u to the 5th minus 1/3 u to the 3rd. And then you have to back substitute. So remember, u was cosine theta. So we have 1/5 cosine to the 5th theta minus 1/3 cosine cubed theta. But we have to substitute again because we made an original substitution all the way back here. We said that x is sine theta. So we have to work through that with the bounds. Does this look at all like what you were doing in class, or is this very different?
Yes, it does. I'm
Okay.
confused with the When I asked why the sine theta went underneath the.
Yeah.
um,
So we set u equal to cosine theta, and then you take
Uh-huh.
a derivative of both sides. So
Right.
that becomes minus sine theta d theta. The d theta is what you solve for, so you move the minus sine theta under the du.
Okay.
And then it would go, because you're just substituting
Right.
back in for each of these pieces.
Oh, right. Okay, I understand. I understand.
Right. And it's, and so the again, like we got this down to I mean, we actually did two substitutions here, which I mean, I think there was an easier one, but we didn't do this. I didn't give you this the best, but x is sine theta. So we have to go to our triangle here. Here's theta. Okay. And sine theta is x, which is really x over 1. So that's x over 1. So this is over here is the square root of 1 minus x squared by the Pythagorean theorem.
Uh-huh.
Okay. And so your cosine theta, which is what you want, your cosine theta is square root of 1 minus x squared over 1, as it's adjacent over hypotenuse. So these become 1/5 square root 1 minus x squared to the 5th power minus 1/3 square root 1 minus x squared to the 3rd power, because you're just substituting that back in. And that's what you evaluate from, I guess, 0 to 1. If we go back to the original problem that you sent.
Uh-huh.
Just looking here to see if that's, so if this at all feels overwhelming, I mean, this is Calc 2.
Right.
It's this over and over and over again. So actually, it looks like at 1, both of these integrals go to 0. Because
Or
you,
don't we need new bounds? Because in terms of
I back substituted the original variables. And that's why I don't need new bounds. I like to back substitute depending on the problem. When it gets really complicated, I try to go back to the original. You could, so we would have had to do it at this step.
Uh-huh.
So this would have been from 0 to sine of 1. And then we would have had to do it again here at this step.
Uh-huh.
We would add, make it cosine of 0, which is 1, and then cosine of sine of 1, which would have, it still would have resulted in going back to getting this triangle to get all that. So like my suggestion is in this problem to go back to the original bounds.
Could you walk through how you did that? Went back to the original again?
Yeah. So it started here at the first antiderivative, 1/5 u to the 5th minus 1/3 u to the 3rd. That's just the power rule.
Uh-huh.
U is cosine theta because that's what we used right here.
Uh-huh.
So we plug that back in to get cosine to the 5th theta minus 1/3 cosine cubed theta. Okay. But then it's like, well, wait, our original function wasn't in terms of theta, it was in terms of x.
Right.
So if you go back, our original substitution was x equals sine theta.
Right.
So if x equals sine theta, I made this triangle here. So let me redo that part, because I think that's probably what's very unclear. So if you draw a right triangle and you label that theta, sine of theta equals x, but we're going to call it x over 1. So sine is opposite over hypotenuse, x over 1. That's this right here.
Uh-huh.
To find c, you got x squared plus c squared equals 1 squared. So to find c, x squared plus c squared equals 1, c squared equals 1 minus x squared, and then you take the square root of both sides. So c equals the square root of 1 minus x squared. So that's this side here.
Okay. Okay.
So that's where it became, okay, well, we want, but that doesn't even answer your question. We needed cosine theta because we need to substitute in for cosine theta.
Right.
So cosine theta is adjacent over hypotenuse. It's the square root of 1 minus x squared but it's over and over 1. And that's the substitution we made for cosine.
Okay. All right.
All right, so is that okay?
Yep.
So now we got to evaluate the integral here. We're still not even done. The top bound is 1. When you put 1 in for x and x, you get 1 minus 1, 0, 0, it becomes 0. So you get 0 minus 0 minus, now we got to do the bottom bound. So when you put 0 in here, you get 1 minus 0 squared, that's 1. Square root of 1 is 1. 1 to the 5th power is 1. So you just get this coefficient 1/5. And then over here, it's the same thing. 1 minus 0 squared is 1. Square root of 1 is 1. 1 to the 3rd power is 1 minus 1/3. So it all boils down to that.
Okay.
So that's 3 over 15 minus 5 over 15. Looks bad. Looks like it's gonna be negative, but then there's this negative out in front. So it ends up being just 2 over 15.
All righty.
$43, you said?
Yep.
All right, now that I know what we're doing here, these will go a little bit faster to explain. So I sent you kind of a reference sheet. There's also, if you go to this page, I'll send this in the chat here. I really like this Lamar. They got a lot of good stuff here. There are only 3 trig substitutions that you need to know, and it depends on the form. So I'm going to snip
Oh,
this
yeah.
in. Go ahead.
We have that chart in our notes.
Great. So the first one was this form right here. That's why we used sine. The second one is in this like x squared minus a squared. So it's in the form of secant. So we're going to make this t equals secant theta, because it's in this form. It's got the variable squared minus a number. Variable squared minus a number. Is that okay?
With the expressions we have are a squared minus x squared, and then a squared plus x squared, and then x squared minus a squared. Those are the 3 we have.
Yeah, that third one is a secant substitution. Do you see that in your
Oh,
notes?
yeah, yep.
And that's what we've got here. We've got x squared minus.
What's that b squared mean?
Well, they can be more sophisticated. Like there could be a 9 in front,
and
then that's your b is 3.
Okay.
This doesn't have to be 1. It could be 16. They can get really messy.
We haven't had anything with the.
Yeah.
Okay.
Okay, so your t squared is obviously secant squared, and then you have to find dt. So that's why you had to go through your calc 1. Your derivative of secant is secant tangent, I think. I feel like I always have to check myself on that because I don't remember. Yeah, derivative of secant is secant tangent. Okay, so we're going to use these 3 things. And again, my preference is not to deal with the bounds yet. Okay, so it's 1 over t cubed is secant cubed theta, and then it's square root secant squared theta minus 1, and then dt. You asked me, dt is this all this on the right here? It's secant theta tangent theta d theta. So we just transformed this. Let me know when you get that down, or if study that and make sure like you got it.
Okay.
Can I keep going here? Sorry, I
Yep,
didn't
good.
know if you're ready. Okay. So the secant squared theta minus one, that's that ends up being tangent theta. So there's three trig ones you got to remember.
Right.
So that becomes tangent of theta. This is tangent of theta, so that cancels. You see, and that's really
Mhm.
critical here. These cancel. This secant of theta goes with one of those. So you have integral 1 over secant squared theta d theta from all this. But you can even do more because reciprocal of secant is cosine. This becomes cosine squared theta d theta.
Or what happens to the -1?
Secant squared theta minus 1 is tangent.
Oh, right. Okay, sorry. Yep.
Yeah, no, the good question. And all of this comes from, you're gonna get irritated with me. There's another trig cheat sheet, and you got to know you got to know a bunch of the stuff in this cheat
Right.
sheet.
Yep.
I'm going to send that to you again in the chat. I would, if you can, I'd print these out while you're doing them. I'm going to snip in the ones that we're going to use today, because again, there's those three identities you got to know, and they're right here. We get those in the notes. You got to know those three really well. Now you get down to this and you feel really good, but if you don't know the double angle formulas, which I'm about to snip in, you have no chance to do this. So there are double angle formulas for sine, cosine, and tangent, and that's what we're going to use here. So this third line here, cosine of 2 theta equals this, 2 cosine squared theta minus 1. That's the one we're going to use. We're going to solve for cosine squared theta in this line here. Okay, so do you see how you have to add 1 to both sides and then divide by 2 to get cosine squared theta by itself?
Yes.
On this? So it becomes cosine 2 theta plus 1 equals 2 cosine squared theta. Divide by 2, divide by 2. Cosine squared theta equals cosine 2 theta plus 1 all over 2. So this whole thing right here becomes cosine 2 theta plus 1 over 2 d theta. And now you're in business. Now you can actually integrate this thing. This 1/2 comes out. I would just bring that out. So you got 1/2 integral cosine 2 theta plus 1 d theta. Antiderivative of cosine is sine of 2 theta, but chain rule, you got to put a 1/2 there. Antiderivative of 1 is theta, and you put that there. Let me know if there's anything that's not clear before we move on.
Good.
All right, so the issue though is that we didn't do any of this in terms of theta, right? We started way back here with this. We said t equals secant theta. So we got to go back to our triangle. Okay. So our triangle, here's theta. Secant of theta is the reciprocal of cosine. So if this were cosine, it would be t over 1, but since it's secant, you got to flip those and put t up top and 1 on the bottom. If that's not clear, it's t over 1 equals 1 over cosine theta. If you solve for cosine theta, you get 1 over t, which is how this worked. So finding the third side of the triangle here, the b, you do the 1 squared plus b squared equals t squared. Okay. And then you solve for b. 1 plus b squared equals t squared. So you end up getting b equals t squared minus 1, square root of that. Okay, so that's this triangle stuff. Now you actually have a choice here, and that's where I'm not sure how to lead you down. You can either solve for theta directly, or you can solve for sine of 2 theta. But I think because of the way this problem is done, I think they wanted you to solve for theta directly. So you can either say here theta equals the secant inverse of t, which I think is a little weird, but that does work. Or you could go down to like this line down here and say theta is the cosine inverse of 1 over t. I think that'll be a little bit better for us. So I'm going to go with this one. So I'm going to simplify. It's 1/4 sine 2. Now instead of theta, it's cosine inverse 1/t plus, and I got to distribute this in, 1/2 cosine inverse 1/t. And now we're ready to bring in our original limits of integration, which I think went from -2 to 2. If you look back at the original problem. No, square root of 2 to 2. I'm sorry. Square root of 2 to 2. Okay, so we're almost there. Is there anything in here you want me to cover again before I move past it? We're just going to evaluate the
I'm good.
integral.
I'm good so far.
Okay, so this is 1/4 sine of 2 cosine inverse 1/2 plus 1/2 cosine inverse of 1/2 minus 1/4 sine 2 cosine inverse. Now it's 1 over the square root of 2, but you're supposed to know that that's really square root of 2 over 2. 1 over square root of 2 becomes square root of 2 over 2. And that'll help with figuring out the angle. And then it's 1/2 cosine inverse square root of 2 over 2 for the same reason. So now we just got to go in and find these values. Okay, so cosine inverse of 1/2 is, well, I'm going to look at my unit circle. I'm tired. That's where the x value is 1/2. So that's pi over 3. This is 2. This becomes the sine 2 pi over 3, 1/4 plus cosine inverse of 1/2. We just found that it's pi over 3 minus 1/4. Cosine inverse of square root of 2 over 2 is pi over 4. So this is sine of 2 times pi over 4 plus 1/2 pi over 4. Okay. Now you got to find the sine of 2 pi over 3. That's the square root of 3 over 2 times 1/4 plus pi over 6 minus, this is the sine of 1/2 of pi over 2. That's 1. So that's 1/4 times 1 plus pi over 8. So we are almost there. It's the square root of 3 over 8. Okay. And then we've got minus 1/4 plus pi over 6 plus pi over 8. And from here, you can combine these, I guess, if you really wanted to. But if you get to this, you're pretty much 99% of the way there.
All right. Can we do number 47 now?
Yes. All right, 47, same page. Okay, so when you look at this, it's x squared plus 16. So that the ones that you were showing me are going to not work as well as these ones here, because this one's got the full forms on there. Let's snip it down here. So on yours, you're looking for a plus, so that's a tangent, and this a, like it could be an either order. It could be b squared x squared plus a squared. But what matters here is that you have an a, you have this other number here. So yours is going to be x equals tangent for tangent of theta. It's the square root of that number is why it becomes 4. Okay, so x squared is 16 tangent squared theta. Dx is 4 secant squared theta d theta. And now we're going to just substitute in. So on the top is dx, that's 4 secant squared theta d theta. On the bottom, it's the square root of 16 tangent squared theta plus 16, like this. All right, let me scroll up here. Please tell me if anything is unclear about this. So we can. jump into it before we move on?
Good.
All right, now
Oh,
on the bottom here, if you were to factor this out, you would factor, you get the square root of 16, and then you'd have tangent squared theta plus 1. And if you recall, you can break these apart. You can do the square root of 16, square root of tangent squared theta plus 1. Those trig identities that I showed you earlier, I'm going to grab them up here. Okay, so this square root, the tangent squared theta plus 1 is secant squared theta. So this is 4 square root of secant squared theta. So this is 4 secant theta. So the bottom reduces to that.
mhm.
Is that okay?
Yep.
Okay, so this whole thing becomes, the top stays the same, 4 secant, is it a squared? Yeah. Secant squared theta d theta over 4 secant theta. I actually like this one a little more now. The 4's cancel, that secant canceled that one. It's integral secant theta d theta. And if you have your table,
Mhm.
this one is kind of, you're kind of supposed to know it. I don't put this in the category of like, yeah, you should remember this, but your instructor might have that be the case. So I'm trying to snip this in here. This one is like, it's a known one in a table. So you get it down to this line and then you can just write the answer.
All right. Yeah, that looks familiar.
Okay. But you are not doing it in terms of u or theta. You're doing it in terms of something else. Like you have to go back and look at your substitution. You said x equals 4 tangent theta. And I think a lot of students don't do this, like they don't get this down. You have to do it in terms of x.
Mhm.
So x over 4 equals tangent theta. You draw a right triangle. You put theta there, tangent of theta, opposite over adjacent, x over 4. Okay, if you need it. But here we just need theta. So theta is the tan inverse of x over 4. So wherever you see a theta, you got to put in this tan inverse. So it becomes natural log, absolute value, secant of tan inverse of x over 4 plus tangent of tan inverse x over 4 plus c.
Why does it turn into tan inverse?
You can't leave it in terms of theta because your original problem was in terms of x. You have to go back to the original variable. So you have to remember that substitution. This was your original substitution. Sometimes you draw the triangle and sometimes you just directly solve for the angle. In this case, you directly solve for theta.
It turned into tangent inverse because you would
You just undo tangent with tan.
right. Okay, and then you just move it up to the top.
Yes.
Okay, all right.
And like if you haven't seen this in class, like get used to like horrible.
Yeah, I remember one where it was this natural log. We did a lot of examples like this problem where, could you go back up?
Sure.
Where go down a little bit more. Right there. Where the two numbers, the 16 and the 16, they had to be the same in order to actually do the problem.
Right. That's because you're factoring out the 16 and it's the square root of 16 times this thing that's left over.
Right.
And then what you're doing here is the square root of a times b is the square root of a square root of b. And it has to be a perfect square. Like that's just the, well, it doesn't have to be, but most of these textbook problems are like that. And that's, that's why this blue table I was showing you a little better, because it reminds you that if there's a number here that's not 1, you have to change your substitution or it doesn't work. Now we haven't done any partial fractions and we got 10-ish minutes left. Do you want us to move to that, or do you have another problem here you want us to?
I want to do another problem like these. Oh, hang on. The problems we just, hang on, let me. Which one do you think would be better to do, number 48 or wait, hang on. Number 48, 49, or 52?
All right, you said 48. Okay, so 48 is a tangent like we just did. 49 is like 42, so it's a sine. Then what was the other one?
Do 49. I want to do 49
Okay.
because the partial fraction we just got done doing those, so it's a little bit more fresher on my mind.
Okay. Yeah, that partial fractions are strictly testing your ability to do partial fractions. The integration is easy relative to that, and easy meaning it's not as hard as the fractions part. Okay, so here again, I got to go back to this, like, and again, like you should realize, like, Matthew doesn't remember this. It's not because I'm not a student, it's because like there's just too much here to remember. So I always look up stuff like this. I mean, you got to remember for the test, but you're this form right here, and your B is 2 this time. So that means you got a 2 there. Your A is 1, so that's going to be a 1 and a 2 in this problem. So you got to get the right substitution first. If you don't get the right substitution, you cannot do these problems. And if you choose the wrong one, this root will just get really messy. So let's square this. That's 1/4 sine squared theta. So there's 2 things. You square it and you take a derivative. Your dx is 1/2 cosine theta d theta. All right, so now we're going to rewrite this integral. It's the integral square root 1 minus 4 times 1/4 sine squared theta. Your dx is 1/2 cosine theta d theta.
Can we go back to the x part?
Yes.
Where you were choosing what's x?
Yes. Okay, so like your problem, let me write out a squared minus b squared x squared, and then let me write out your problem. Your problem is 1 squared minus 2 squared x squared. And your substitution is a over b sine theta. So your problem is 1 over 2 sine theta. You have to be able to match these up.
Why is b2 if it's 4?
Because it's 2 squared. Then it's whatever number is squared gets you back to that.
Oh, okay. Oh, so it wouldn't be 4 squared?
No, it'd be 2 squared.
Oh, okay.
But that's where 48's a little weird. It ends up being the square root of 2, not 2, because when you square the square root of 2, you get 2. You look at 48, that's a little wonky. Okay. But again, like if you didn't do this right, what we're about to see would not work out, because you're going to see that it becomes 1 minus sine squared theta. This has to become something that you can do something with, that you can use a trig identity with. That's the whole section, trig identities. Okay, so this square root becomes the square root of cosine squared theta. And then that becomes just cosine theta times 1/2 cosine theta d theta. So you end up getting 1/2 sorry, that's not right. That's not squared because you square rooted it. So you end up getting cosine squared theta d theta as your integral. And then from here, you got to use double angle formulas.
All right.
So before I snipped in all of them, you really only need the top half here. And these last 2 rows are cosine 2 theta equals that. But we're going to use this one. So this is definitely worth remembering. You will get this on a test. This one you got to solve for cosine squared theta, this thing on the right. So if you remember, you add 1, you divide by 2. Cosine squared theta equals 1 plus cosine 2 theta all over 2. So this part right here, we're replacing with, we're replacing with this goes there. So it's 1/2 1 plus cosine 2 theta over 2 integral of that.
What happens to d theta?
It's still there. Sorry. It is still there.
Okay.
Yeah, you better write that. The instructors will mark you for that for sure. So it becomes 1/4. I'm going to put the 1/4 on the outside. 1 plus cosine 2 theta d theta. So this becomes 1/4 antiderivative now. Theta plus, it's sine 2 theta, but chain rule requires you to put a 1/2 there. Okay. And this is plus c. Okay. But we have to go back to our original substitution. Remember, we said x equals 1/2 sine theta. That was the very first step. So we need to solve for theta. So we get 2x equals sine theta. Theta equals the arc sine or inverse sine of 2x. So wherever you see a theta, you got to put that back in.
Alrighty.
So yeah, there's a lot here, a lot here. I mean,
Uh-huh.
we've only done 5 problems or something in 47 minutes. So these are,
Right.
you don't get as many on your tests either, unless you got a longer class. But they're all very hard. I assume you already did an integration by parts,
Yes.
and you've done U substitutions. So you
Yes. I
generally
was
get
very confident though.
good.
Yeah.
I was just going to say,
Same.
usually you get like one of each type on your test. You get one partial fraction, one trig substitution, one integration by parts, one U
Because they're
substitution.
so long.
That's right. That's your test. Like it's,
At least that's nice.
but there's so many of each that it's like, which ones do I, do you
Yeah,
study?
true.
Can't tell you. If you got old tests from the teacher, that's always a good thing to look at if you can. Is there anything I can talk you through the next 2 minutes? Or just start
Um,
for 48, or I think you said maybe 50 or 52.
which one did I say? Have we done with like 48?
Yeah, but it's a little bit wonky. Let me go through the substitution on that, because
Okay.
it's not clear. So go back and grab this. So this one is this last one down here.
Right.
Okay, so let me like try to summarize that. You have let me rewrite this one. This is the square root b squared x squared plus a squared, and that becomes x equals a over b tangent of theta. Yours is 1 squared t squared plus square root of 2 squared in your problem. That's this bottom part. So your b is 1, and your a is the square root of 2. So your substitution is 1 over the square root of 2 tangent of theta.
Or y is square root of 2.
That's the only way, because your a
Right.
when squared has to get back to that.
Right. Okay.
So that reminds me. So if I were a student again, and maybe this will help you, I wouldn't necessarily do all these problems, but I would get to figure out the substitution for all these problems. And I would like work to figure that out, and then maybe like substitute them back in. But getting this substitution right is critical. If you get this wrong, you will never finish the problem. So like if you want to do 51, just get the right substitution. Figure out which one it is, get the right A and B, map it to yourself until you like got it. I got it. And then the rest is just squaring and substituting and a few other things, but you got to get this down to move forward.
All right.
All right. Well, I really appreciate you scheduling. I'm looking forward to helping you. Again, if you need physics help, please consider my services. I'll send you
Yeah, I'm
the
gonna start doing physics as well.
excellent. And if I'll send you the notes and the screen recording here shortly, and I hope you have a great night.
All right, you too. Thanks.
Have a great night. Bye now.